All right, so today we are going to work on, this is stuff from chapter 9. We've got translations and reflections. And so we have two essential questions. Essential question number 1, how do you write a transformation notation for a translation? Essential question number 2, how is the notation for a reflection in the x-axis different from the reflection in the y-axis? So go ahead and pause so you guys can copy that down onto the pre-made notes given to you. All right. So the first main idea is translations. And so first we have some vocabulary terms that are just for transformations in general. We have what's called a pre-image, and a pre-image is the beginning figure. This is the given figure that you're going to start with. The image is the resulting figure after the transformation. So after you do the translation, reflection, rotation, dilation, whatever it is that we're going to be doing, the image is the resulting figure after you perform that operation. Then the one we're going to talk about first is a translation. And a translation is a transformation that shifts all points of a figure in the same direction and the same distance. So transformation is very similar to like Transformers, for instance. Optimus Prime, he goes from a Mack truck to a robot. Okay, and so he's changing something about himself. So in a translation, what's changing here is the figure's position, but it's gonna still be the same size and shape. So translation just changes the position, the location of where it is. It's gonna shift it all in the same direction and the same distance, but it's not gonna change the size or shape. So the pre-image and the image of a translation will be congruent figures. So in a translation, it's what we call a rigid transformation, meaning that the shape and size stay the same. So the pre-image and the image will be congruent figures to each other. Okay. All right, so example 1, let's do some coordinate plane stuff. So translate the given figure 2 units right and 3 units down. So first what you need to do is graph the points and label them. And it is important that you label your figure. So this is our pre-image because this is our beginning figure. Okay. So now all you're going to do is we're going to take each point and move it the way they tell us to do. So I'm going to take point A and we are going to change my pen color here. So then I'm going to take A and we're going to go 2 units to the right and 3 units down. Now what we're going to call this is A with an apostrophe here, and we call that A prime. And we talked about that in chapter 6. So we've moved that, so now it becomes A prime. It matches the original point that it went with. Then B will do the same thing, 2 units to the right, 3 units down. It's okay that it's inside the other one. And then 2 units to the right and 3 units down for C. That becomes C prime. So again, notice that I did not make this image, A prime, B prime, C prime is the image of ABC, but it's not a different size. So remember, it preserves its same size and shape. So if you graph it and one looks way different than the other for a translation, you've done something wrong. Okay, so that's part A, we already graphed. Part B says we want to list the coordinates of the image. So A prime is at 5, -1. B prime is at 0, 1. And C prime is at 3, -5. Okay. And then the last part, part C, is what we call a transformation notation. We could put a capital letter in front like this. And that capital letter really doesn't mean anything. It's just naming this transformation. You can T, you could put R, you can put W, whatever you want, or they sometimes won't even put a letter there. And so what this says, it's kind of like a function. So we put this in, we're going to put the original X and Y in, and then we're going to do something to it, do something to the X and do something to the Y. Well, since we went to the right 2, do you think I would add 2 to X or subtract 2 to X? Well, since we're going to the right and those are positive numbers, we would take the original X and add 2. That's the equivalent to moving 2 units to the right. And then we take Y, since we're going down 3, that's equivalent to subtracting 3. So basically what this means, if I go back up here and put the original A values in, so A was at 3, 2. So if I plug that in, that would be 3 plus 2 and 2 minus 3, which, yeah, that's what A was. The coordinates of A prime came out to be 5, negative 1. So this transformation notation acts like a function. So if I input the original point, so when I put in A was 3, 2, so the X value was 3 and the Y value was 2, if I plug that into this function, that gave me the image point of A, so A prime. And you could do that with all of them. If you plugged in B here, that'd be negative 2 plus 2, which was 0, and then 4 minus 3, which was 1. Okay? So whenever you're doing a translation, if you go to the right, you're adding to X. If you go to the left, you're subtracting from X. And for the Y's, if you're going up, you would add to Y. And if you're going down, then you're subtracting, because up for Y is positive and down for Y is negative. Okay? All right. Now these you could do these without graphs. Okay, so here's some other ways that we could do this. So what is the image point of P, which is at 3, negative 5, after a translation of 2 units down and 5 units up? So go ahead and pause, and I want you to try that one to see if you could come up with the image point for that. Okay, so we're at P is at 3, negative 5. So then if we are going to do 2 units down, which is that the X or is that the Y if I'm going down? That's the Y. So it should be 2 units down. I'm going to subtract 2 from the Y. And then 5 units up, that's still here. So I would add 5 to the Y. So actually we're not going right or left. So we leave Y alone. Okay, so P prime then is going to be at 3. Negative 5 and positive 5 cancel each other out, so we're left with negative 2. Or you could think of it as negative 5 plus negative 2 is negative 7, plus 5 gives you negative 2, however you want to think of that. But that one had us going up and down, and so really down 2 and up 5 gave us this. Okay. All right, example 3. This time, they're giving us the pre-image and the image, and they want us to say what is the translation for this. So go ahead and pause, and I want you to talk with your group and try and figure out what the transformation notation would be for that. Okay, so typically what I'll do is I'll put these on top of each other. So I'll put like this, and then I'll leave a space and put A prime, which is 3, negative 9. Then we ask ourselves, okay, so what happened? What did I do here? Because you know you have to add or subtract a number because they said it's a translation. So negative 3 plus something gives me 3, so that'd be plus 6. And negative 8 plus something would give me negative 9, which would be negative 1. So negative 8 plus negative 1 is negative 9. So then your notation would look like this. So you can describe it this way, or we could say translate, because we do need that vocabulary term. We could say translate 6 units right and 1 unit down. Okay. All right. And on example 4, they want you to describe it. So they already gave you the transformation notation, so you can't use that as your description. So now you got to write it out in words what this means. So what happens on this one? Now you do have to use that vocabulary word of translate. Or you can say a translation of blah, blah. But if you want to write less, you could just write translate 2 units up. And that's it. Because we didn't do anything to the x. We didn't go right or left. Okay. So those are the different ways on the EOC they could ask you about translations. Okay. All right, so on the left-hand side of your notebook, go ahead and write your own translation notation and describe it in words. So this doesn't go in a skinny column as an example, although you can do an example later on this. I want this on that blank sheet of paper off to the left. Write your own translation notation and describe it in words. So you can probably do. All right. Our next main idea are going to be reflections. You can go ahead and turn it to the next page of your notes and at the top write reflections. Your main idea. So a reflection is a transformation. So again, something's changing. That plots each image point so that it is the same distance from the reflection line as its pre-image point. So we'll be reflecting over lines here. And again, this transformation, the pre-image and the image will be congruent to each other. We're not changing the size and shape, we're just changing its location. All right. Now, I don't want you to do anything. I just want you to watch and participate here with some of the questions that I have. All right, so on this one, let's take this and we're reflecting over the x-axis, which is this red line that I have here. It's the red horizontal line. So if I were to take A, what it means is that A is 4 units above. A is 4 units above the line, so then A prime has to be 4 units below it. So A prime then is at -2, -4. So -2, -4. So B is 5 above. So then B prime would be 5 below, which would be at 0, -5. C is 3 above, so C prime would be 3 below right here. So that's at 1, -3. D is on the line, so it's not going to go up or down, so it just stays the same. And then E is 2 below the line, so then it has to be on the other side, so 2 above it. So there's where E would be. And so E then is at -1, +2. So what do you notice the pattern is here? What's happening from A to A prime, B to B prime, C to C prime? Well, hopefully you're saying that you notice that all of the X's have stayed the same. Those are all the same, but the Y's have all changed to their opposite. Okay, so now you'll pick up your pencils and write this under where you wrote reflection. Whenever you're doing the reflection over the x-axis, that notation is going to be the same all the time. It's where x stays the same, but y becomes the opposite. Because when you're reflecting over the x-axis, if the point is above the line, then you go below the line. If the point is below the line, you're reflecting so it's above the line. Okay, so that's why this notation is the same. Now, this is not like translations where translations change based on the problem. So, right to, left to, up, down, all that kind of stuff. Whereas the reflection over the x-axis notation, this is always what it's going to be. The x stays the same and y changes to its opposite. And so how I remember it is that if we're reflecting over x, that doesn't change. It's the other one that changes. Okay. All right, now let's look about if we're reflecting over the y-axis, which is the vertical axis here. Okay, so A is 2 on the left-hand side, so A prime is going to be 2 on the right-hand side. And so that's at 2, 4. So you're not doing anything here, you're just kind of helping me out here. So 0, 5 is on the line, so that stays. C is 1 on the right, so then C prime has to be 1 on the left. So that's -1, 3. 3, 0 is 3 to the right, so then D prime will be over here, which is at -3, 0. And then this is 1 away from on the left, so E prime will be over here when you reflect, which is at 1, -2. So what do you notice is happening here with this notation? Well, notice that all the y values stayed the same. It's the x values this time that changed to the opposite. And since 0 doesn't have an opposite, that's why it was just that one, because it was on the reflection line. Okay, so now pick up your pencils and copy what's in red. That's the new piece of information. If you're reflecting over the y-axis, your x changes, but y stays the same this time. And again, how I remember the difference between the two of those, whatever axis you're reflecting over, that variable doesn't change, the other one becomes its opposite. You guys can pause at any time. All right, now here's the ones that are a little harder. Okay, so this one we are reflecting over the y equals x line, which is this red line I have. And y equals x means the points that are on this are 1, 1, 2, 2, 3, 3, 4, 4, -1, -1, -2, -2, etc., because the x and y values are the same. Now, since this is a diagonal line, we are going to count diagonally. Okay, so for instance, notice A here. If I'm going along here, this is 1 diagonal, 2 diagonals, 3 diagonals away on that side. So then I count 1 diagonal, 2 diagonals, 3 diagonals on this side. So this is where A prime is. Okay. I'll get rid of that because we don't need all of that. I'm just showing you how to get it. Now A prime is at 1, 2, 3, 4, -2. We're at 4, -2 here. Okay, B, if I'm reflecting, that is 1, 2.5 diagonals. So then I have a half, 1, 2. So here's B prime. So notice B prime then is at 5, 0. C is just 1 diagonal away, so it has to be the same, going in that same direction. So there's C prime, which is at 3, 1. D is on this side, so it's 1.5 diagonals away, so 1 or half and a 1. So C or D prime, I'm sorry, would go here, which is at 0, 3. And then the last one, maybe you can see the pattern now. E is just a half diagonal away, so E prime will be right here, which is at -2, -1. So what's going on here? From the A to the A prime, B to the B prime, what is happening? Well, hopefully you're saying you're just switching around these coordinates. The signs and everything stay the same. You're just switching the spots of the x and the y. So -2, 4 becomes 4, -2, 0, 5, 5, 0, etc. Okay, so that's the notation when you're reflecting over the y equals x line. That will always happen when you're reflecting. So if you don't like the whole counting diagonal box stuff, then this is the notation. They give you a point, you're just going to switch it around. So what the original y was, that goes first now, and what the original x was, that goes second. All right, one more reflection that you'll be responsible for on the EOC, so you don't have to do anything here, you're just kind of helping out, is reflecting over the y equals negative x line. So that's this line here that divides these two, quadrant 2 and quadrant 4 in half. Okay. Now again, we're still going to measure diagonally. So like A is one diagonal away, so A prime would be here, which is at 1, 2, 3, negative 4, 2. Okay. Then B is 1, 2.5, so half, 1, 2, so it's right here. That's B prime, which is at negative 5, 0. Then C is 1, 2 diagonals away, so 1, 2. So C prime is at 1, 2, 3, negative 3, negative 1. D is 1.5, so half 1, so D prime is here, which is at 0, negative 3. And E is 1.5, so half 1, E prime, which is at 2, 1. So what's the pattern here? What's going on here? Oops. Well, what's happening is you're switching them again like we did with the YX, but we're changing both signs because 4 used to be positive, now it's negative, and 2 was negative, and now it's positive. Here, you're switching and negating, but 0 we can't negate. Here, switching and negating, so it's like the contrapositive. Okay, so the last one you'll have to be responsible for knowing, and they won't be giving these to you on a formula sheet or anything. You have to know them. Is the reflection over the y equals negative x means you switch them and negate the signs. So copy that down. All right, so let's do some examples of how you're going to have to do this. All right, so go ahead and graph the original and label it. Little itty bitty triangle. Okay, and we're going to reflect it over the y equals negative x line. I'm actually not going to draw that line in. You could if you wanted to, but what I'm going to do is I'm going to work backwards. I'm going to do part C first because that never changes. The transformation notation for reflecting over the y equals negative x1 is always the same. Then I'll do B, then I'm going to graph. So I'm going to go backwards this time. So we know the notation for reflecting over the y equals negative x line is when you switch and negate both. So then to get A prime, A was originally 0, 3. So what do you get when you switch and negate it? Well, you should get negative 3, 0. So then A prime is at negative 3, 0. Okay, B prime. So the original B was negative 2, 2. So we switch and negate. So this y value, which was positive 2, now becomes negative 2. And this negative 2 changes to its opposite, which is going to be the same. And that's because B is actually going to be, would be on that line. So negative 2, 2. And then C, if we plug this in here, C is at 1, 2. So we're supposed to switch and negate, so that'd be negative 2, negative 1. So C prime is at negative 2, negative 1. So these, with the reflections, it may be a little easier to work backwards, especially with those diagonal lines, if you remember the notation, which you need to. And now I'm just going to graph it. So I'll change colors here. So negative 3, 2, that's a prime, negative 2, 2, so that is C prime, and negative 2, negative 1 is C prime. Now again, notice it's the same size and shape, so I didn't mess up or anything like that because those should be the same. Okay, so that's an example of a graphing one. All right, example 6. What is the image of point A, 3, -5, after reflection in the x-axis? Now with these problems, you don't want to end up sketching the problem and then actually reflecting it over that x-axis. So this one, what was the transformation notation for a reflection in the x-axis? So x stays the same and y becomes its opposite. So if I plug in a, which was at 3, -5, what would a prime have? 3, +5. So that would be your answer. Because when you're reflecting over the x-axis, the x stays the same. It's the y that's changing to its opposite. All right, example 7. This one is actually asking you to do a double reflection. It says, what's the image of B at -3, 4 after a reflection over the y = 2 line, which is this horizontal line, and then reflect that point over the y = x line? Okay, so manually if I do this, because this one y = 2 doesn't really have its own little transformation formula, so I'm just going to perform that. So B is 2 above that, so B prime needs to be 2 below it. So that's where B prime is. Okay. Then we're reflecting this point B prime over the y = x. Well, B prime is at -3, 0. So remember when you reflect over the y = x line, what do we do with those coordinates? Right, we switch them, so that should be at 0, -3. So this, and we would call this B double prime because it's the image of this B prime, so that's why we have to add another slash there. And so that point is at 0, -3. So then my final answer is that after both reflections, your final point, your final image point is at 0, -3. So they may ask you to do some double reflection. So this one we had to do manually. So B was 2 above y = 2, so B prime will be 2 below, which is at this coordinate -3, 0. Then when we reflect over the y = x, you could have counted diagonally, which is 1.5, and then plotted it, or you would just remember that for reflecting over y = x, you flip those, just switch them around. So 0, -3 is your final answer. All right. And that concludes notes for today. So there is a worksheet that you're going to do. There is no electronic choice to do it, so everybody's going to do paper and pencil. So work on that for the rest of the time. This is not an optional one. You do need to do it because I will collect it and make sure that you completed it. And the answer keys should be on Schoology.